Dr. Van Leeuwen comes to our community as a professor of the School of Geography, Development, and Environment and the School of Natural Resources and the Environment at the University of Arizona. He is the director of Arizona Remote Sensing Center and is the interim director of the School of Natural Resources and the Environment. Dr. Van Leeuwen's research and interests are focused on understanding soil and vegetation ecosystems and how they respond to climate and human interactions, mainly focused in the Western United States. His research efforts seek an improved understanding of long-term landscape scale dynamics in forest and rangeland ecosystems. We are fortunate as a Santa Catalina Mountain community to have his interest also focus on understanding ecosystem responses to and the effects of wildfire, water erosion, and management activities. Current research projects revolve around decision support systems and the integration of remotely sensed products in geographic information systems in order to monitor natural resources. In particular, to our community, Dr. Van Leeuwen and his department, the School of Natural Resources and the Environment, have worked diligently to bring back the life to the beautiful Fall Preserve, to continue to educate the public of their research, and to create a bridge of learning from the University of Arizona to the Santa Catalina Mountains. So please join me in welcoming Dr. Van Leeuwen to our community, as we are so honored for his presentation that he will present to us regarding the Bighorn Fire in Santa Catalina Mountains. Thank you. Thank you very much.
It's a pleasure to be here. I'm going to put my mask back on, I guess, since that's the prudent thing to do. I'll leave you saw my face for a little bit. You always can find me on our own websites, very likely too, right? So anyway, it's a pleasure to be here, and I'm going to talk a little bit about a variety of different things that I do in the Arizona Remote Sensing Center. Like it was said before, I'm the interim director too right now, but this gives me less time to do research and do more administrative work right now. So as Christine said, it's really hard to actually do everything at the same time, but nobody stepped up except me, I guess, or they actually wanted me to do this job for the interim director. We actually are also trying to find a new director right now, so hopefully this person will come in probably later next year. In the meantime, I guess they can see me like this, they can see that. In the meantime, it'd be very interesting to actually work on the Fall preservation area. We have several other places in the state of Arizona where we do work, and I'll show you some of it today in these slides. So this is kind of our mission, where we do a lot of different things related to decision making and providing information and products that allow people to actually manage the landscapes in the Southwest. And today I'll show mostly the things related to the Santa Catalina Mountains. This is our building. You have seen it on campus. The University of Arizona is the Environmental and Natural Resources 2 building, and we are mostly on the 3rd and 4th, a little bit on the 5th floor on the north side of the building. So it's a public space, so if you feel free to stop by sometime and see what's going on there. Most of the time I'm in my office if I'm not in the field. So a lot of the things that we are doing are related to wildlife, to rangeland. The state of Arizona has a lot of land that is being managed by ranchers, by Forest Service, right, for rural land management. We also have a lot of, so our work that's related to wildlife habitat, to recreation, ecotourism. We do a lot of watershed management too, related to erosion, looking at what the impacts of the droughts and the variability every year in terms of our rainfall. And of course, we have fire all over the state. We look at weeds and invasives, native species that are around, and people go out in the field, of course, and now they have a lot of forage and livestock in the state of Arizona, a big industry here as well. The tools that we use for our research are very varied. As was introduced already, my focuses mostly on geospatial informatics, that we use satellites, we use airplanes, we use drones, and we use actually handheld instruments that actually they'll talk to each other in many ways. So, but you get different details from the different platforms. So that remote sensing is what I'm going to talk about the most. But also other faculty in the school, they actually look at molecular and genomic biology. They do quite a bit of work in climate modeling and forecasting, where you look at the relationship between those and the impact on our forests and our landscapes. Other people work on carbon and the fate of nutrients in the soils and how things are affected by fire, things like that. Do lots of surveys related to wildlife surveys, related to management, and see how different management practices actually affect the different landscapes and the health of the different ecosystems. And then you do some water quality monitoring as well. But this is a busy slide that just gives you an overview of what my job is at a university, just to give you a little bit of a bigger overview. I do research, instruction, and actually I couldn't do that by myself. Actually, there's several people in my lab group, Tyler Hartfield, Jeff Gillen, Cindy, several students that work with me. I'll talk today mostly about some land, forest, water, a little bit about it. I think mostly about the Bighorn fire. Then we have research going on with the Agricultural Research Service, the National Park Service. We do lots of different work related to actually optimizing and creating new products that allow us to actually make informed decisions and manage our landscape based on the information that we get, this satellite data and other data sets as well. I talk about some websites, DroughtView. It's actually a website where we actually bring the NASA data out to the public, and I'll show you how to do that. And you actually can go to these websites yourself and play with the areas of interest to you. And we have some story maps that actually give you an overview of all of these projects, a few slides basically that are on the web that you can look at. I actually teach as well. Currently, I'm teaching a unmanned aerial systems class. I teach some remote sensing courses. We have a GIS program. And then these are the people that I work with. They're all having a good time, as you can see. I said smile so we can take a picture. So this has been the way that we've been communicating. Everybody's actually communicating through Zoom still. There's a few people in the lab now, like Patrick here. He's actually working in the lab. We're required to wear masks at the University of Arizona. So especially in small spaces, outdoors, you don't have to. But Kang and Elizabeth are students, and these are all staff. Actually, Kyle is a professor of practice, so he teaches a lot of courses. But he's also a research scientist in the remote sensing center. And feel free to interrupt me, any questions that you might have. But we might save that for later too. So remote sensing Earth is a little bit of a grainy picture, but it actually shows you an annual cycle of how vegetation grows around the world. And this is based on a satellite from the Terra platform. It's orbiting the world about 24 times a day and actually basically observes the whole world every day. And then if you put those data sets together and give them a nice color, you actually see that dark green is actually the vegetation, and that the Sahara Desert is the Atacora Desert. Some other deserts right here in Chile as well, in Australia. You see also here on top, the North Pole, but we don't have much information. You know why that is? Any idea? Well, as people have been in Alaska here, so is it always sunny? No, right? So it actually gets really dark a big part of the year. Well, and to measure the vegetation with satellites, you actually need to have sunlight. It needs to have sunlight reflecting back so you actually can see vegetation. So during parts of the year, as the sun basically is not coming up there, we can actually not measure anything in those parts of the world. But basically, white is basically snow or desert, and you go up to the dark green colors, you get tropical forest, right, basically. So, and I'll explain a little bit how we do that, but basically this is trying to filter out all the clouds. You actually get rid of all the noise, basically, and try them to actually make an image for this, for the whole world. Every 16 days, we get a new image, basically, that we put together, and then you actually can create time series to actually see what's happening throughout the world. And we have these data sets for the last 30 years, so that's really important that we actually maintain that continuity of these data sets so we can see where things are changing. So, can I bore you with some technical stuff? So this is the sun, right? So the sun actually is really hot and basically emits a lot of energy. That energy comes and reaches the Earth. Well, this is the part of the what we call the electromagnetic spectrum that we can see with our eyes. And that's basically what satellites can obviously observe too. It's like if something is green, like you see here for a plant, this is what we call a signature for a plant. If something is green, it's because it reflects more light in the green wavelengths than it does in other colors. So yet your red shirt, it actually doesn't reflect as much in blue and green, but it reflects more in red, right? So blue is something that it doesn't reflect in the other colors as much. So that's important to see. It also shows you here that the sun puts out a lot of other energy that we cannot see with our eyes. So it actually puts out energy in this part of the electromagnetic spectrum, as we call it. So from 0.4 to 0.7 is what we can see. The rest of that energy we cannot see, but satellites can. They actually can create detectors that actually can see that energy that's coming from the sun and then gets reflected back out from the Earth's surface. And this is what it looks like for vegetation. These are water absorption. There's water in plants, so they can absorb more energy. This is chlorophyll, how plants photosynthesize, so they can get absorb a lot of energy. And then the structure of the plants in the near infrared, it actually reflects a lot of energy. So, but that's important because green vegetation looks very different from soil. Like if you look at soil, it's brown, maybe reddish, dark black, maybe gray. Well, that's if it looks like gray, it's because all these colors are pretty much reflecting evenly, right? So it becomes gray. If it's snow, they all reflect really bright, and it's white. Well, in this case, you can see that it's a very different signature. And then if you have water, it's also very different too. We take advantage of that to actually use satellite data to characterize what we see on the Earth. It's not only the colors that we see, but it's also different things that you can see that are related to how the vegetation burned in an area. And as you can see here, if it's a healthy vegetation, that signature is that looks pretty green there, right? And it has very characteristic. But if you have high burn severity, it looks much more like a soil. Everything is gray, black. It's like a soil almost. And hence, the signature is very different. And then everything in between, you can see that falls in between that really healthy vegetation versus that soil. Sorry, I'm not going to talk too much. So actually, so there's a, apologies, let me turn off my phone.
And I apologize with my laptop. I thought I turned off it. So
actually then quantify how severe a fire burned. We actually use part of the electromagnetic spectrum here in the near infrared, but you can see there's quite a few differences. And we use the short-wave infrared, this is pretty much somewhere here, right? So you see lots of differences, and you basically see a reversal of the near infrared is low, high for healthy, and here for burned area, it's high in the short-wave infrared and low for the green vegetation. So we take advantage of that. We actually quantify that, we measure it. These are reflectances, right? So that's a between 0 and 1, you basically get, if it's snow, it's almost close to 1. If it's actually a peaty soil or something dark, black rocks or dark soils, that index becomes close to 0. So between 0 and 1, you basically have a whole range of vegetation densities going up to the tropical forest. So this is then what we take advantage of those differences and actually create an index, as we call it. We actually provide information then by quantifying those things. So here we're getting closer to, and if some of you might recognize, this is the poster that we put on the fall property a couple of weeks ago. And it shows you a satellite image, mostly focusing in instead of looking at the whole world. That you can zoom into part of the world. In this case, it's Santa Catarina Mountains, the Rincones, Santa Rita in the Red Zone Mountains, and you see some of the riparian areas of San Pedro and some other areas that you see Eric as well, maybe. But you see that when something is high, it meant that there was a lot of vegetation. Right, so then after the Aspen fire, so this goes back to 2000, it's hard to see maybe, but this was basically the seasonality. So things go up and down in the season, but you have green trees, right? So it stays pretty high, goes down that, but then after a fire, it really goes down, it destroys all the vegetation after the Aspen fire. And basically then after that, you see a recovery. You see seasonality a little bit, but you see a recovery. Not necessarily all pine trees, but there's definitely going to be vegetation cover preventing erosion and things like that. And you see these dips down, that's where we couldn't find any clear images. It either was cloudy all the time for 60 days, or it was, or there was old snow on the ground. And quite often it's in the winter, as you can see, January, you have these cloudy days or snowy days. So let me show you a little bit how this will work. And in this case, we're going to go to this website. Can you get it yet? No. There you go. So this is what we call DroughView. It's a website, everybody can go to it, and it actually shows you satellite data and other data, so you actually can see and zoom in to anywhere in the US, particularly where we are focusing on. If you enter it, there's actually a few explanations here. But here you basically see the whole US, and there's different ways of looking at this. And you can zoom in to Arizona, and as you zoom in, you're actually going to see more and more information. So you get basically contextual information as well as you see the satellite data. And there's a legend there that actually gives you the interpretation of these images. And what you see here is what we call DERS. It's a satellite up there that passes over. They have all kinds of other data sets. Let's say you can go to Modus. It's a different data set, but what you can see here basically is that you also can have a dual panel. And then you actually see, in this case, let me put Modus up here. And as you zoom in, let's see, where were we? Tombstone. You can zoom in on the Santa Catalina Mountain, right? So obviously, you can see the Catalina Highway going up. You see the streets of Tucson. You see also the patchy landscape after the fire. Now, if you want to go back, so this is, you see here, there's a date here, right? It's the 1st of November, 2021. If you go back, we actually can go back a long time. Let's see, did you notice? It doesn't like this. All right, so if you want to go back in time, if you click on this, and you can go all the way back to November. Let's say you want to go to March, right? You click on the date and see what you see, right? It's actually very different. And that's related to all the fires we've had. But this was the healthy Santa Catalina Mountain. There was already some fire. Well, was the public fire already happened then? Maybe not.
Yeah.
Oh, you did. So on this side, you basically see that. See if we can go further back or not. So you have 2001 data too, but no. So as we then go after the Aspen fire, we actually can do that here too. I think you can notice here. So you can actually see the set of different dates. But let's go after the fire. Let's say you go to August. And you see there's a big difference in terms of what happened with the whole mountain range, right? This is the difference from here. You see actually, you also have other data sets here that actually gives you an indication there's less green. So all that orange basically burned. So all of a sudden you can see where it burned, where things were not burned. It's actually, of course, around Summerhaven and other places where they protected the International Observatory or Bigelow area. You see it didn't burn. Then if you go further down dates, actually you see that things are recovering too, right? So you see some recovery, and it was a really dry year, it looks like, so there's less green all around the mountain. 2009, I don't know if you remember 2009, but so as you go through this, you can play with this yourself. And we can go to August this year. And of course, we had an enormous green and wet year this year, right? So everything became really green around the mountain, except for, and that was the difference from the previous year, right? So all of a sudden, it was very dry last year. It starts to rain, you get a really the difference from average too, and you see there's a difference. It didn't recover, so you have a difference with average here as well. And you can see that the mountain never recovered. It was less green from average, but everything around it basically recovered really well because of the rainfall. But this is a website that you can go to. You also have precipitation data on it, I think. It's climate data, so you can do look at some forest data. You have some fire data on it as well, in terms of where the fires are. You can zoom out. You can move to somewhere else, right? So play with it, and if you have any questions, send us an email, and we go from there. Okay, so I'm going to go to the other website, the other slides again. So just DroughtView. We also have a site called SnowView that actually looks at all the snowfall in the state of Arizona. And actually, you get some here on Mount Lemmon too. You actually do this work for the Mogollon Rim area where we have the White Mountains, and where the White Mountains actually provide a lot of snow, but actually they catch a lot of snow, but they provide a lot of water for the Phoenix metropolitan area, right? So all that work, you can go to SnowView, and you actually can zoom in on the Catalina Mountains, and actually once in a while you see a little snow patch showing up. But in many ways, we do this to look at stream flow. So if there's a lot of snow, we actually can predict how much water is going to come down the mountain. This is important, right? Because that's I determine how much water you get for your lakes and things like that. But it also can be after a fire, you might get a lot of water coming down and get mud flows or disasters that could happen based on all of that. So we provide information to Pima County. They actually contracted us to actually provide a lot of different data sets for them to actually interpret and also manage the different aspects of the Bighorn fire because of all the erosion, mud flows, risk for different neighborhoods, basically in the Cañada del Oro area, particularly. They are very afraid of water coming down too fast, basically. So we have a number of, so like Christine said, like we provide decision support tools. It's basically we provide information, geospatial information, to our managers like Pima County, and provide information so that they can make informed decisions about what they want to do. So we're going to try this again. Where does it work? There. So this is what we call a story map. We actually have the location of where the Bighorn fire was. Then we have imagery from satellites that shows you where the fire occurred. And this is basically where fire managers, firefighters, they use these kind of satellite data to kind of see where they actually can put in some fire breaks, see where there's hot fires, and then actually maybe try to manage the fire. Or you can see this. So these are story maps based on our research. So what I talked to you about before, those reflectance values in that the sun provides us basically this information about how things are reflecting. You can transform those data sets from the satellite into severity of fire, where the dark green is where things didn't burn. So there's all these pockets, including like around the area here, right? The Bighorn fire didn't really catch that, of course the Bigelow area as well. So this area didn't burn, but then everything else, that upper CDO watershed, that burned very this high severity. You probably all are familiar with some of these areas as well. So quite a bit, the red really deemed very severe, the moderate for yellow, and low for light blue. So you can see the magnitude of the fire, and then you can actually compute the areas and the distribution of those of the fire in CDO, for instance, where Pima County wanted to know what part of that area did burn, what part of the watershed did burn, so we can quantify them. The Dino watershed, and so forth. So besides using satellites, it's all nice and good, right? So those are basically synoptic views, bird's eye view, actually far away satellite views of what we see there. And that's not what you really can interpret very well. You know, kind of in general sense, what is where is the high severity, but we actually use drones to actually get more of a detailed view of some of these areas as well. So this is Jeff Gillen. He uses a DJI drone that has very high precision GPS on it as well. and he basically has a remote controller, and he catches it out of the air because it's pretty rough terrain, so you can't really land it. So actually, he lets it sit. He catches it out of the air after he's done. So this drones, they actually have a very affordable way of actually creating very detailed what we call elevation models of the terrain, where we actually see the little distribution of the streams, basically where there are steep slopes and so forth. So we actually process all these images, just color photos. We process them all together. I'll show you at the end of how we do that. We actually create a very detailed map of where the steep slopes are, and actually if you do that multiple times, you actually can see where erosion occurs too. You actually can see where things are deposited, where things are being eroded away. And then we also can actually create colorful point clouds, as you call them. They basically show you where the trees are. You can see here clearly where trees are, where the ground is, basically. And we basically quantify this to see then, well, what are the number of trees, what kind of trees are actually still standing after the fire came through here. All right, so bear with me. Here we go. So we also have a web application. And there. So there's a web application too, and I can send you the link. But basically, here you see the outline of the Bighorn fire. There's all kinds of information. Again, it's like you can put a watershed boundaries. You can put the Bighorn subbasins on there. There are some batch plots that we actually put out. So we actually go out in the field and actually go in there and we can zoom in, as you can see. And we have basically plots out here that allow us to get more information. So actually Don Falk, a professor also in the School of Natural Resources, he's a fire science professor, and there's him and other people, we actually go out in the field and actually start monitoring how the fire has been affecting these landscapes. So this is actually a very rich website. See, there's actually also an area where Jeff Lewis drone. You can see here very detailed information. You can see the tree trunks and the trees just sitting out there. So really get a really good distribution and information about what we find in these areas and how severe those fires were. So we have several students and Jeff and other people working on this, and we'll provide you with more information as we get more findings. So there's more projects. Let's see. Let's go to some other work done by Jim Malusa. So that's the ignition of below the Bighorn Peak that started the big fire, and Jim basically is he's a field ecologist and does a lot of work and goes out and does a lot of what we call repeat photography. So there's another way of actually monitoring over time what happens in different places. So this is a light burn, Aspen and Bighorn. There's a 208 picture where you can see those trees. They actually fell down after a number of years. So There's a rare cord-barked fir in this area that's only found here in Santa Catalina Mountain, in the Coronado National Forest, and Mount Grady, you can see it as well. Another picture here where you can see kind of the 2008 after effects of the Aspen fire, and kind of some snags here, as you can see here, and here you see a lot of the snags are disappeared, and you also see there's a lot more green forest that disappeared. So repeat photography is another tool to actually keep track of what's happening and how we can maybe do better in managing and keeping a healthy ecosystem. Another area that didn't burn a whole lot, it's changed over time a little bit. There's some different scrub oak here. Here, that's the fire that was the shovel fire. There's a lot of debris left, and then the bighorn came through it again and actually burned a whole bunch of more of these trunks. You also can see how things are recovering. So you see a resprouted silverleaf oak here. So quite amazing. After a big fire, some of the resprouting species, pines, if they have a crown fire, they don't resprout right, but these resprout, and again, is keeping track of that. There's no repeat photography here, but he's going to probably go back here. So this is in Cañada del Oro in 2013, very lush landscape, and all of a sudden after the fire, bighorn fire, you see everything burned, but then already some kind of maple is actually resprouting and coming back in place already. This is actually what we are afraid of, right? Where you see the 2013 picture from Charles Miles, and Jim Malus took another one, and you see that rock here. All of this was eroded away out of the mountains. All of this debris and soil basically came out of the mountains and filled up this whole creek. So all of a sudden you see basically all the biodiversity that we are proud of that in the Sky Islands, right? Where we go from basically from the desert up to the forest, from here to Canada, basically, that we are really losing a lot of biodiversity here in this creek because of this erosion that came down the mountain after the fire. But yeah, so that's basically a big deposit right here, and that's why we're providing this kind of information to King County, so they might be able to reverse or maybe put structures in place that prevent some of that erosion, and maybe also do some planting. Another one here, 2012, this is all kind of depressing, but you see also things resprouting, but then some of the trees got a crown fire and they will not come back. So he basically estimates that at least for 30 years, we wouldn't see any pine trees anymore in that area. Go back to the fire using satellite data, my expertise. Again, where applying that equation where reflectance in the near infrared minus the short-wave infrared reflectance divided by the sum of the two allows us to actually create an image. If you create an image before the fire and after the fire, you actually subtract the two, you actually can see the difference, and that's what you actually see here. So it's a difference between before the fire and after the fire. That's how you can actually see the severity of the fires. You should be familiar with this. This is where Jeff has been flying some of his drone to get more information for different locations about the severity of the fires and what kind of species disappeared. These ones are still coming back and things like that. So it's going to be a repeat over time, but he did this in June 2021. There you see, again, from the air, from this drone, you actually can see very clearly the snags and the trees and where things burned, where it didn't burn. And then actually you can use that information to actually see how much timber is there left, how much shrub is still covering the soil. Those kind of pieces of information is what we can have a lot of detailed information for, but then the satellite data sees the whole mountains because we can't fly a drone over the whole mountain range. So we actually have to do detailed information at some spots, and then you extrapolate it out to other places using other data sets. So this is then a 3D view of just taking pictures and then actually processing it in a computer and creating a 3D scene that actually allows you to see the forest, you see the dead trees, you see the live trees, and we're going to be continuing doing some of this to do this. So our whole setup here is actually get information in the field. And so we now have a lot of detailed information about the trees, the diameters, the number of trees that died, and their crown width and height. You can do that with a drone. And more, this new technology is what we're exploring to actually see how we can actually use that and optimize it. So in difficult terrain, like here in the Catalina Mountains, you can't go everywhere. A drone is much easier to use in some of these kind of dangerous places in many ways, right? So where you have snacks coming down and debris coming down. And so we have also, as you've seen, you have some airplanes flying over once in a while as well. And we get detailed information. You have LiDAR data that gives you similar information as the drone does. It's just a lot more expensive. And we have satellite data that's pretty much free. So what Jeff then is doing, what are we doing this time? Pretty good still. What Jeff is doing, actually, he's actually combining that field data, the drone data, and the airplane data. And then, and then he has the National Agriculture Imaging Program as well. That's 1 meter data. It's like, you see basic pixels. It's kind of coarser, but he's using then Planet as well. Planet is like a company that has 60 what they call CubeSats. They're really small satellites. They're actually orbiting the Earth as well. They get 3 meter resolution data. But what he does here, he basically is identifying the live trees and shrubs, the background, the dead trees and herbaceous data layers, and then doing the same thing for after the fire. So that's allows us then to actually look at risk and see where we might have dangerous erosion circumstances as you go up to Ski Valley, right? So that's the road up to Ski Valley. So that's what Pima County is asking us to do, to kind of create these maps, but also creating them into the future to kind of see how well we gonna get recovery, where other species might come into its place, and hopefully protecting our soils and our houses and everything that we have here up in the mountain. This is another poster that you might have seen in the Fall property. So hopefully is my explanation. This should be making sense even more now, but hopefully this kind of explains it to some degree as well. But you can see where you have basically information from a different satellite, again, Sentinel, all kinds of different information. And here's the Fall property. So another poster that you've seen, I hope, on the Fall property, which is actually there in the winter. I guess it was this year that I probably flew the property December 2020. So I went there. There was some little bit of snow on the edges, I think, but I don't remember for sure. But you can see I flew the drone. I did this manually, actually. It's normally we don't do. We actually program it to actually, but I was there for a short time period. I brought the drone. I wasn't sure going to fly. I didn't see too many people. Because as I'm a drone pilot, official, formally, FAA approved, and we're not supposed to fly over people, right? So that's where I want to be careful if you fly over people that they should be knowing that you're flying there. But this basically shows you every red dot is an image that I took as I flew over. I actually flew fairly straight flight lines manually, but you actually normally can program it in advance and actually do a better job and don't have too many gaps like you see here. But then you see here some of the road here along the property, and then you can actually also look at the site, right? So if you can, and something we can talk about, but we actually can create a virtual reality in many ways where you actually can walk through the forest if you have enough detail. That wasn't my intent. I actually did it for Mrs. Fall, to actually show her that the property looks good, send her the imagery and the data, and it was just a test to see if you want to continue tracking this information over time. So what I'd like to show now, let's see if that works. So this is then the program that we use. So we collect all this data with the drone, we download it in the lab, and after that we're basically see and put the images all together. So they're all separate images. And let's see. So this is basically every location is an image basically. So you can see a smaller parts of the property. And then if you go down here, we actually can then actually rotate it and actually look around and see from different places. So if you zoom in, you get to see my car there. Super just parked out in front. I don't see too many people walking around, but it's basically very detailed information, right? So you can see and actually could walk through. So the drone can penetrate the forest, right? It can look from all kinds of different angles and actually see some gaps here and there. But this one, it only can see what it can see from the top, but it can't really see anything through the canopy. I have a new drone that has a LiDAR system on it, so we're going to try that out sometime and see, because that actually does a lot better job in penetrating and looking at more gaps. But this is optical. This is just your camera on your phone, just in a drone. It actually has a GPS. The camera itself is on a gimbal, so it actually doesn't vibrate. It just like keeps really stable. But it also has a GPS in it, so on your phone you have a GPS, right? Everything is in that drone and allows you to know where the pictures are taken. So then once you know where they're all taken, you put it in the program, and it all basically puts it together. You create an auto photo, or you can create a 3D image. So this is then without showing where all the images are, but you can obviously see and play with it. And I see there's nothing in the house there because you can see through the roof, right? This was not to spy on anybody, but just to show you.
Dr. Van Leeuwen, I'm sorry, that's Karen's cabin.
No, excellent.
Means me running around back there naked.
I saw that. Then I shut it off right away. But you see kind of the aspen, I think. The leaves that are not on these trees, like in the pocket area there, you can see the different trees. There might be some definitely ponderosa pine. I'm not sure there's any Douglas fir in there, so if you analyze it, you can actually start counting the trees. You can measure the height of the trees. You can do all kinds of things that we think the file property will be a good teaching tool for students to actually do these things. Be on the ground as well, measure the thickness, the diameter of the trees, things like that, and actually play around with it. So, so there's also then just a mosaic where you can straight down. You can see there's these edges here, and that's where the car is basically. You can zoom in.
Wow.
So you want to see the people there? So anyway, so that's the program we use. So you collect all these images, and this was a really quick project. But normally we do a double grid where we actually fly basically north-south, and we do an east-west grid as well. So then you actually even have better information than this one here. So this is really detailed. Cameras, technology is getting better all the time too. So the more comes out, the more we try out and see how we can use it for natural resource management, decision making. We bring these data sets out on the website so people can use it for their benefit, and everybody has the same information to hopefully make agreeable decisions. So I think that's close to, I mean, I'm always impressed by these things, of course. So are you, I hope. So that was the last slide. And you have my email there, so feel free to send me any questions. But if there are questions, we can back to some of the slides. Yes.
Well, I'm wondering, what are your plans for the fall preserve in the future? Do you have any specific vision or plans for it?
So we hope to continue doing so the change detection and flying it over and using it as a teaching tool for our students in the school. We hope to engage the students that can come out more often. Since I'm the new director, I can actually, I've been engaging the student clubs for them to come up here more often and actually take advantage of the area to kind of do more of an inventory, kind of keep track of what's going on. Work with Charles van Riper, and see what his information gives us. There's limited amounts of funding that we have available to actually do a lot of different things, but I'm just going to maintain the property as best as I can. I get reports once in a while from you, so then I come down and fix things where needed. And there's more things to be fixed, right? So that's something that I can't really do the next day, but I'll be coming up here more often and I'll go from there. So.
Can you get your students to assist you in the maintenance of the preserve? I mean, can they be involved in projects on the preserve?
Students in the University of Arizona, yes, they can. Because basically there's a liability issue, so you actually always have to make sure that they are employed by the university when they come out. And then most of the maintenance I've done by myself quickly, but I know there's still things to be done.
I wonder if you can repeat the questions, please.
Repeat the questions.
Okay, so the question is the future of the fall preserve. It was pertaining to the fall preserve and to have more of the students from SNRE, the School of Natural Resources and the Environment, to come and do the maintenance and upkeep of the fall preserve. And the answer is yes. And it would be solely from the students there because of liability and so forth. So, and Dr. Van Leeuwen, I do have a question here. It says, from your research, what are the changes of a major fire burning the Sabino Creek watershed and the green envelope that remains after the Bighorn fire since the drought continues? Can it be prevented?
Can the fire be prevented? Well, I think nature takes its course, right? So if drought sets in, we don't have a lot of things we can do. There are efforts going on throughout the state of Arizona to actually do forest thinning activities. So actually in around Flagstaff, there's a lot of forest thinning going on. I think down the Marshall Gulch area, there were a lot of firefighters actually thinning out and getting rid of brush there just a couple of months ago. So there are things going on in different places. So if this information provides too dense a vegetation structure where we think the fire risk is high, there should be things that can be done. It's just a matter of do the land managers, the Forest Service actually go in and actually prevent. And I think they are sensitive to that based on what I've seen recently. So, but yeah, if there's a lot of dense forest and low understory growth, then it becomes like a ladder of fuel, basically, that when it takes off, you can't really stop a whole lot.
He says, thank you.
The other thing I was going to say, though, what are your ideas for the fall property? What do you think could we do? What we want to do, or that are within a reasonable?
There are so many programs at SNRE of the the insects and everything that Dr. Michael Bogan is
Yeah.
interested.
Uh-huh.
We would love to have them here, whether it be in the community center or outside. We're not very formal, so we can sit outside.
As you can see, I'm not very formal either.
There's also research on I think the noxious flower, the botanicals, and so more of understanding those
Okay.
so that we can help our community identify, how to address it when we see it here. There's also, I believe there's a wilderness student society or club, or it's anything that the SNRE can show, our community and the kids. I think those are really wonderful.
Yeah, so it's just a matter of for me sending out an email to my faculty and the
Okay.
students and say, hey, there's an invitation for you to come up. We have
Okay.
people that are experts, like Michael is definitely an expert on
Yes.
insects, and Dr. Howery is a noxious weed expert.
Mhm.
Maybe as much in the forest, maybe he is, but he's definitely in the rangelands
Right.
specialist too. So we have the Terraseka Club, we have the Wildlife Club,
The wildlife.
so we have
club.
all and we have the Natural Resource Graduate Student Club as well. So I think that there's definitely, it's a matter of planning it basically a little bit and then have people come up and
Okay.
maybe do some more displays. We could do some posters. We can have a rotating poster display too, right? In terms of,
Right.
we talked about fungus and other things
Yes.
that you wanted to
Fungi.
display.
Yes.
Yes.
I'm on the committee with Christina, and thank you, Christina, for spearheading this whole project to preserve so that we can use it for education. So we can use it for children, for children's tours, and somehow incorporate it into the TUSD or the type of field trips and programs or have educational botanist tours. It's not a school, but it can be a store.
You want to be
It's
the
just
tour
that-
leader yourself or?
That's
Dr.
right.
Van Loon, please repeat the question.
I'm the one who needs to be educated.
Okay, but once you're educated, you might be able to take over.
Well, they have volunteers in Sabina Canyon.
Sabina Canyon.
Fantastic that it's on through
Yeah.
the educational process.
It's the Northern Desert
You know,
Museum, yes.
So it's just like, like to see it maintained and preserved and used in a way that really. And so we thank you for whatever you can do to help us do that.
Yeah, no, it's my pleasure, and
Yeah.
getting the feedback is really important, and I think I'm getting some more feedback all the time right now, so it's good to be able to do that, and it's kind of fun for me to actually come out here, and I like to go hiking here anyway, so take that opportunity to
Yeah.
put some more things out there and provide your feedback as you see things. I know there's a few things that still need to be fixed, so.
Yeah.
I do have a question on your presentation about what we have here in one other place.
Mount Graham.
Graham here. The only place, and it's endangered.
It's a rare.
It's a rare.
Yeah, it's rare. I'm not sure how it's endangered. I mean, I'm not a specialist in that. It's just Jim Malusa basically knows where they are, and he goes out in the
Well,
field.
when you go on any of the trails, you can see them right around here. But they are so special. I mean, they really look like fur.
Yeah.
Fur.
Mhm.
If like that would be really interesting to do a program, or what we have up here that is nowhere else.
Let me just pause to restate this. So the question was, if there could be a presentation that goes deeper into explaining more about the cork bar fir tree that is rare, that's either up here or on Mount Graham. And so that was a request or an idea. So.
Any other questions?
I just have a question on your beautiful pictures of the Bighorn fire. Did you provide those to our foresters, Or do they have a means of doing that? Because those are some of the same pictures that we saw when we met University, where the firm was and where it was.
I think they do a lot of themselves. They do work with the Forest Service, we work with Pima County. So these data sets are available by the USGS, basically. USGS is actually getting all the Landsat data, they put it in an archive. The way different people manipulate the data different ways, that might be a little bit of a difference, but quite often these things get spread out and used by a variety of different agencies and the university. So it's all the same data, very likely. It's just maybe slightly different display, or for us, it's fixed to do. We have a computing facility at the Remote Sensing Center that allows us to ingest the data, download it, and then make these images.
Are fascinating.
Question, can SNRE help research ways of controlling cheatgrass?
Oh, I'm sorry.
I was going to say, like, the websites that I showed you, you actually can go to those and actually look at them yourself, right? Play with it and zoom in on different things. So.
At a later time, may I have those links to be able to share out? Or,
Yes.
Yes. Okay.
Yes.
And then I think we have a question
Sorry,
from. No, I'm so
question.
sorry. Dorothy, what was your question?
Can the department help us with research to find ways to decrease or help control cheatgrass, which is a big problem here in terms of fire risk? And it's different from rangeland situations just because the flora that we're dealing with beside it is different from rangeland challenges. So whether it's whatever agencies might help us control it, it's very hard. There's too much of it to hand pull it all. And I don't know if your program anywhere in your program would be look at something like that.
Let me repeat the question to the audience. So the question is, can the department help with the issue of cheatgrass for our community? And basically, I'm just asking that in general. That.
Some of our students go out to the washes to actually pull buffalo grass and go out to different places to actually help preserve some areas.
Mm-hmm.
Large areas with cheatgrass or buffalo grass, it's very hard to control. And that's just a very hard thing to do. I mean, if you burn it, you might get it out of hand. You get a prescribed burn maybe. But man, it's once it's there, it's really hard to I mean, I would say be firewise around your house, but other than that, there's not much you can control to do. And it's not what we are doing, so it's something that the Forest Service do, or
My question had to do with research and whether research in terms of agents that could be used to control cheatgrass, or even mechanical kind of a gatherer, something would cut and pull, cut and suck up at the same time. It could be developed as a research project.
Yeah, not my specialty, so I can see where you can use herbicides. Definitely, you can use herbicides if it's not spread out indiscriminately, right? So you actually can do a targeted herbicide and put that on. I mean, that has been done in different places. They tried to do it in the desert too. And for buffalo grass, they killed a whole bunch of cacti because they weren't really focusing on. So that's, herbicides, I would say, would be one way of doing it. But if you get in steep terrain, that might be a bit tougher. So, but you need to know where they are. So what I would do is actually try to show where all those areas are. And then it's the management agencies that would go out and actually try to figure it out. If there needs to be research done, then that's something that I know some people will be interested in, the plant sciences department and maybe some of our plant science focused people in school as well.
Okay.
So not a clear answer, but tough one.
I have a question. With your drone imagery, would you be able, and when you're using the GPS attached to it, would you be able to pinpoint, oh, I found this wildflower? No. And be able to keep track of that? I know,
If it's a field of wildflowers.
right, but not individual.
Individual, you can do some. I mean, unless it's under the trees, right?
Right.
Anything under the trees you can't see. This resolution of these cameras is really high.
Okay.
You can zoom in really fine and actually see things, but
Mhm.
it has to be the right time. So if you know the phonology and the timing of when things are flowering, you could actually do an inventory maybe,
Okay.
if there's no trees obscuring it, but that's a tough one.
Okay. Okay. Thank you.
That's where you go out in the field and see them yourself.
Yes. Yes.
And you actually can bring a GPS and then know where they are.
So-
Any other questions?
Thank you very much.
Thank you.
Right. Excellent.
Okay, and this,
Did you want to copy the?
I do have a question for you. I'm so sorry. I do have a question. There's one more. This is from, I'm sorry, it's from my son, so I have to ask this.
right.
He says, he's 12, so how could one of my age positively affect the fall preserve? How would he be able to help?
Invite the university, come up there and be
Okay.
participating and coming, letting us know that we need to come up and
Okay,
talk to you, and you can organize the club here and then
there we go.
meet up. If you observe something that you feel like we need to look at, let us know, send us an email by walking around. You see something, take a picture, send us a picture of what you see, and then maybe we can identify it or let you know, depending on the question you have, we can try to figure it out.